weeks ago, I was watching a video of somebody building a golf simulator in their garage using only stuff they bought from Home Depot. I thought it was an insanely cool idea, and my brain kicked into high gear and just started going overtime. I thought, this is really cool. That's something I can do. Then I realized I don't really like golf, so not really super useful. But I do like shooting. So naturally, my brain thought, let's build the ultimate range simulator, dry fire, range training setup in my basement that I could play after the kids go to bed. Why not?
I'm not a smart man.
How hard could it be? Then I had another realization. I know absolutely nothing about video game design. So I installed Unreal Engine and started playing with it to see what would happen. And that's where we're at today. Welcome to Devlog 1. Let's dive in and get started. So to give you a little bit of background about who I am, just a normal guy. I have a family. I have a degree in fitness, so that should be insanely helpful on this project.
Push it out. Everything you got. Everything you got. Everything you got.
I used to shoot back when I was in the Marines. Did a couple US PSA matches, but lately life's gotten busy. I haven't really prioritized it, so I haven't been to the range in years. So this project hopefully gives me a chance to kind of feel like I'm back in the range and have some fun without having to spend a lot of money on ammunition or spend a lot of time away from the family. So what I'd like to do now is talk a little bit about my goals, which I think will transition well to design principles, and then talk about the architecture and what exists today in the game, and maybe any potential issues that I've run into. This is the first video I'm making, so I didn't do a great job of recording all of the stumbles and trips and bloopers that I did along the way, and I'll try to do a better job of that moving forward. And then where I see the game going in the future. So first, the goals. There's 5 goals. The first is that I want to be able to build this thing for under $500, but I think I can do it for under 500 and have a pretty sweet system, pretty sweet setup. That's probably on par with multiple $1,000 systems. The next is I want this to be realistic, and I break that into kind of 2 categories. The first is visual, and then the second is the feel, or the physical. So for the visual standpoint, I want it to have realistic physics, have good graphics, have instant feedback so there's not lag or delay, and so it'll lead to design principles of creating something that's very efficient code, so I'm not wasting a lot of processing power on things that I don't need to be. So visuals, I want it to look snappy, and I want it to look realistic, so that you kind of feel like you're there-ish. So it'll have to sound loud, like you're either firing a gun indoors or outdoors. There'll be muzzle flashes. Should look the part. The second is the physical aspect of it. So I want a weapon system that matches or feels similar to the weapon system that I currently own. I'm looking for some recoil, the ability to draw it from a holster, being able to reload. I want that aspect of it, because again, I want it to feel realistic, and I think there's more training value if it is realistic, which leads to the next point, which is training value. I want to be able to collect data. I want to be able to hopefully use this to actually get better. Flexibility, that's a big one. I want it to have flexibility both for the player and for me when I'm coding in the back end. Building a system that is dynamic, that allows me to make changes on the fly and adjust the functionality or add features. So flexibility is going to be important. Instead of hard coding things in, using variables. And then lastly, the biggest goal here is to learn. not just learn how to shoot, but to learn a new skill, learn how to use Unreal Engine. I imagine this project will probably go until I feel like I'm not learning anymore, or my ADHD brain gets distracted with something else. But it's going to be very important. I have a tendency not to finish projects, so once I feel like that's happening, I need to wrap this up. Maybe I'll post it to Steam or something. But to learn and to have an actual end to this project. So as far as design principles go, we talked a little bit about that. The number one most important thing is flexibility. Designing in such a way that if I want to build a new drill, I don't have to spend all day reprogramming, rewiring, adding a bunch of mesh, making something really difficult to read when a new coder comes in or somebody else looks at it. I want the system to feel intuitive. I want it to be easy. To spend a few minutes putting together a new drill, throwing a new target in, and now you've got your new drill set up. And if I can make it incredibly easy for the builder, then I might be able to even build a custom drill builder in the game, potentially, again, down the road. And then again, efficiency. If I'm going to add a bunch of features, if I want physics to feel real and lighting to feel real and muzzle flash, and I want all of this realism, then the code needs to be efficient so it doesn't get bogged down because it's trying to calculate where to put 50 bullet holes. So efficiency is going to be important, paired with the flexibility and the realism. Let's talk now about system architecture. How is the system currently designed? How's it built? How does it work? When the game begins, a player is spawned in. Think of that like a camera with a gun. There's not an actual player. You can't control the camera, where it looks, where you move. It's stationary. But this tells the game where's the gun fired from, where are we looking when the game begins. It also brings in a referee. Think of the referee like a blind umpire with a clipboard. And that referee, the first thing he does is he looks at a database that has a list of all of the drills. And in that database, every drill has a name, has a target image, has a target blueprint for how that target is supposed to work, where the target's going to be located, how the target gets scored, whether that drill has a par time and whether that par time ends the drill or not, potential starting sequences, audio. It's got all the information that it needs to run the drill. So the ref will then set the drill up and the starting sequence will play, and at that point the player can begin the drill. The player will then take their shots and will ask, did I hit a target or did I miss a target? And if it hits a target, it passes that information to the ref, who looks at his clipboard and writes down the score, the time you shot, the location, writes down all of this information. It will then, at the end of the drill, depending on however that drill ends in its own drill logic, will then tell the player their score, their accuracy, their precision, and all of that will get displayed on a monitor. So things that will have to be hard-coded is that every target type that has a different animation or different movement will need its own blueprint, its own object. So right now I have paper targets are created. They're the only ones. Eventually I'll add steel targets. I'll add steel targets that move. I'll add a few different targets.
So, I know I just talked to you guys a lot about what was happening. I figured I'd walk you through so you can actually see what's going on up here and how it all works together. All right? So let's open this bad boy up. So the first thing that happens, as I mentioned in the video, is the player comes to life. The player does not control the camera, does not control movement. It's basically a camera with a gun. So that is created here. And yeah, it looks at the mouse, which will eventually be replaced with a laser firing at a screen or at a projector screen. Right now, for debugging purposes, I have the left mouse button. So when I click, that counts as a shot being fired. When a shot's fired, a gunshot will sound, a muzzle flash will flash, kind of in somewhere in between these two colors. We're going to set color, intensity, delay, and then a line trace will fire. It's basically a laser that comes out of the tip of the gun. It asks, did we hit anything at all? If we didn't, we're going to assume we shot the sky, and we're just going to call it a miss. If we hit something, we're going to ask, was it a target? Like, were we hitting something that was like actually a target? If we weren't, we're going to call that a miss, and we're going to throw a bullet hole on the wall, potentially play a unique sound, add an impulse. So if, let's say, we hit a tree branch, or we hit a balloon or something, I don't know, that impulse is going to affect that target with some type of physical force, but even if we haven't really built it to do that. And then we're going to process it as a miss. If we did hit something, then we are going to begin a series of events called on bullet hit. We are also going to now fire a second line trace. And I'll show you why I did that a little bit later, but essentially it's because I wanted to be able to spawn a decal, a bullet hole behind the target. And so it's essentially going to start a second laser after the target that continues until it hits a wall or the ground or something along those lines. So the next thing we need to look at is on bullet hit. So that comes to our target blueprint. Now this is just for paper targets, so every different target type or the way a target moves or functions is going to be different. So I'm going to need a steel target blueprint, a dynamic steel target blueprint if the target moves, a cardboard target blueprint. Every different type of material that I have that is going to operate differently will need its own blueprint. And that's not to say every visual effect will have a different blueprint, more like every physical effect. If steel is going to make a different sound, it's going to act differently than paper or cardboard would, for example. Okay, so basically here it gets created. When it gets created, it gets its own target size. We did this so that we could calculate accuracy and precision. And then we're going to basically create our canvas. We're going to add our art to it. We're going to add the scoring get the scoring mask. This basically just builds our target. Now, once the bullet hits, so on bullet hit, here's that function. We are going to get some values. We're going to animate the paper target. So it should act like cloth physics a little bit because it's paper, although I understand that when shooting paper it doesn't really move. We want it to feel like you're shooting paper, so we want to kind of give it a little bit of that element of movement. Then it's going to go to draw, and this is going to draw the bullet hole, or basically put a hole in the target. It's then going to look at that scoring mask and see what color it hit in the scoring mask. Now, what is a scoring mask? Let's say that this is your target. Whoa, hello. So here's your target. Its scoring mask might look something like this. And this is based off of a universal color palette. So all headshots will be this color, all 7 points will be this color, 8 points, 9 points, 10 points. Bullseyes are 11 points, whatever we want to do. So yeah. Back to our target. So it's going to look at that where the bullet hit, going to compare that to the scoring mask, and then it's going to process the shot. It's going to give it the target reference, the hit color, the shot location, and the target ID. Again, this is important because if we're shooting different targets, we want to know kind of our accuracy and which shots are associated to which targets. So process shot, where does that happen now? So now we're in the referee. Now the referee, like I said, is sort of blindfolded, or he has like horse blinders. He can't see anything except the clipboard that's right in front of him. So when he gets created, he takes our universal scoring palette, where all headshots are that green color, and all. He gets that and he builds that as a variable, and he holds onto it. He's building his clipboard, or printing out his clipboard. Then he sets a few other variables. and he opens up this drill database, and this tells him how the drill needs to be set up. Where do all the targets go? And what do we need to know about the targets? And all of that. So we start setting up a whole bunch of different information, data, and we build out our clipboard. And that's based on this. This is our drill database. You can see here I have 4 drills. So we'll just go free shoot. It's got a name, it's got a thumbnail, which will eventually be used when I've got the menu. A logical blueprint, this will be how the drill function logically. So if you need to, if a target's going to blade when it gets hit twice, or if you're doing a Mozambique drill, 2 shots to the head, to the chest, 1 to the head, that's going to tell the logic, or it's going to tell the referee to end the drill once you've done all of the logic. So that's the next step for me to build. This is a Boolean, so true or false, spawn dynamically. That's adding in some flexibility. Haven't used that. I don't plan on using that anytime soon. Par time. This says, will the drill end when we hit the par time? So if we say this drill should take 4 seconds, at 4 seconds, regardless of whether the shooter is done or the player is done, end the drill. Par time is set here, 0 is infinity. Then target list. So this gives an infinitely long list of targets that you can add to a drill. Each target has 9 data points to it. It's got its actual visual art, it's got its scoring mask, the target blueprint, how do we want this target to act, this is where it's going to spawn, what location. Is it going to spawn dynamically? It looks like that's repeated, so I have to adjust that. An anchor tag, so if I wanted to have different spawn points around a map, I could tell this to spawn at a particular anchor point for this drill. Bullseye coordinates, so you can have as many bullseye coordinates as you want on a target. Here I have 1 associated to the head and 1 associated to that bullseye point. Again, important for measuring accuracy and precision. How close were you to the bullseye and how tight was that grouping? Accuracy being how close, precision being how tight. Max radius, so when we're calculating accuracy, what do we want that max radius to be? Target dimensions, leave that blank. We can now add sort of preparatory commands here, as well as a beep, and then a delayed minimum and maximum for that beep, and how we want it to start. With text, with a full starting sequence, vocals, beep only, what do we want that to look like? So again, the referee will read through this entire list in order to build the drill. So once that drill has been built, it begins. So this is how this begins. We start the drill, and we set a bunch of different variables to make our lives easier. And then we basically have different pathways we go down. Okay, so the full sequence, it's showing text, it's playing vocals. Here's just the beep, so you'll wait a few seconds and you'll hear a beep. This would be like if you wanted to practice draw and shoot multiple times and didn't want to go through the full sequence, you just beep, repeat, so on and so forth. So we go through this string here, and then this keeps track of our par time. So when that par time hits, end the drill, if we've turned that on. This was built in such a way, let me see, where, get active, start time. So I added this in here so that in the drill we can set up how the start sequence goes, but if a player wants to change that, so he says, you know what, I never want to hear vocals, it's annoying, it slows me down, whatever, this will look at what the drill says, what the players asked for, and then choose the appropriate response that sort of mirrors those things. Let's go back to our background. Okay. So once the drill is done, we go to the event end drill. So now I know I can organize this better. I don't know what I'm doing. Learning as I go here. So ending the drill. We ask, is the drill active? If it is, all right, then we can set it to inactive now because the drill is over. We're going to clear our timers. We're going to set our final time for the drill. And now we're going to pull up our scoreboard monitor, and I'll show you sort of what all of this looks like here in a second. And we're going to do some advanced mathematics, advanced metrics. This is to calculate our accuracy and our precision. Now, essentially what it does is it takes a look at all of the shots that we fired and then stored, and it says for this shot, what's the nearest bullseye? And we're going to assume that that is the bullseye that he's shooting for or aiming for. And then it's going to group the shots based on the bullseye that we wanted, and then it's going to say how far were these shots on average away from that bullseye, and it's going to convert it from distance to a percentage. But we can leave it as a distance if we wanted to. In fact, set distance or percentage as a option, question mark. Okay, I'll think about that. Then precision does something very similar. So it loops through, looks at all of the bullseyes, clusters the shots by bullseye, and then looks at how far apart those shots are and returns those as a grouping in inches. This is why it was so important to get the target, the actual target size, because that is what gives us accurate math when we do this. For calculating shot splits, we have to do a little bit of math here. Don't really need to know about that. So then it updates the scoreboard. Update scoreboard is basically just, wait, that's not it. Update scores or update score. Where does this live? Ah, it lives on the monitor. So let me see if I can find this. That graph. No, it doesn't. Where does this live? Well, this is embarrassing. Where's my event scoreboard? It's WPPS. Okay. So the event scoreboard basically just takes everything that it was given and prints it out in something like this. Now, keep in mind, this isn't refined. I was just testing the logic in the back end to make sure it works. So let me show you how these drills look or function. Oh, get out of here. So if we want to go computer referee details, we'll start with our free shoot. That's loud. Sorry, house. To the target. What's behind the target? Not that big a deal. But let's look at. This is my square test. I wanted to see if I could add a square target. So what you'll notice here is that this target does not come all the way down here. It is square. And there's the beat to start the drill. If I was to just drop a square target into here, it would end up being stretched to fill the full space. So what I had to do was drop in a PNG. So it's my square target, but the full image is the actual size of the target. So all of down here is just invisible, but it still reads as the target. So if I shoot here, the game still thinks I hit this target. It's just that the scoring mask sees that as nothing. That second line trace allows these bullets to show up. Without that second line trace, you'll see bullets. You wouldn't see any here. Let me show you what this data looks like when we do this. Wait for the beep. I will shoot. Wait for it again. Okay. So we can see 0 misses, 4 in the bullseye, a score of 40 points. Took a total of 10 seconds because that was the par time. My first shot was 1.371 seconds, and then 0.31, 0.37, 0.63 for the subsequent 3 shots after that. An accuracy of 50%. This is based on an 8-inch radius and a group size of 4.973. Yeah. I think I should... This takes the average distance of these shots from the target, and that's not what I want, because that's a precision question. What I want is the... Well, that would work if we looked at it as a coordinate system, plus and minus, but it doesn't. It looks at it as a total distance. I want to average all of these shot locations to get my accuracy, so I need to change that. 1 second while I think about this. Before I forget, ADHD brain, let's go. Calculate, let's see, average locations to get accuracy, not distance. Okay. Oops. Save. Shift save. Okay. Where was I? I don't know. Yeah, so that's accuracy, that's precision. I'm going to make that change. This is that I wanted to try. My thought for a drill like this would be that it starts close, and every time you hit the bullseye, it moves further back and further back and further back. Maybe there's an easy, medium, and hard mode. Hard mode is you are not allowed to miss the target. If you miss it once, it resets. Easy mode might be shoot as many times as you want. It only moves once that target's hit. We've also got a Mozambique drill.
Is the shooter ready?
You can hear the talking.
Stand by.
And there we go. 76% accuracy, 1.693 inch groupings. Yeah, I think that's it for now. Oh, I am using AI to help me with this. Not in that I'm telling it to write the code, but I'm asking it questions and it's giving me nodes and helping me build out these event graphs, because I have no idea what, I don't know, what a vector 2D length node is and how it works. So I tell it what I want, it kind of talks me through it, and I'm learning a lot. I'm able to catch some of the mistakes it's making. More importantly, I'm learning how to talk to AI to get this to work, but it's pretty sweet that I've been able to do this. Anyways, thanks for watching the video. Let me know what questions you have, or if you have any advice, because again, I don't know what I'm doing. I'm going as I go, so anyone who knows more than I do, please share.